We have a demonstration set up to show the Ripley ZCS or zero cross switching technology and how it compares to other technologies. Our test setup today is a Tektronix oscilloscope, current probe, custom glove test fixture, and a 150 watt LED fixture operated at 120 volts. I will begin by briefly explaining how and what our ZCS technology does and how it benefits both the photo control and the luminaire. The AC voltage is shown here as amplitude or deviation from zero. The AC wave is sinusoidal or a sine wave, meaning that the waveform has a smooth repeatable oscillation. Switching at the peak of this waveform will result in a large inrush of current because the capacitors found on the input of LED fixtures in a discharged state initially act as a short circuit. This inrush ultimately causes the relay contacts to arc and deteriorate before eventually welding closed, causing day burners and added stress to the driver circuitry. The point at which the sine wave crosses zero is known as the zero cross point. Accurately switching at this point inherently limits the inrush potential. This enhances the longevity of the relay in the photo control as well as provides the fixture driver a soft start. Let's take a look at a few units to see how they perform. It's important to note the source impedance in each specific application does affect inrush current. In this test, we will be using the oscilloscope to see the precise switching point. We will be monitoring current with the current probe. This allows us to safely measure the instantaneous surge caused by some of the units when switching on. We will also be monitoring the AC line voltage on a separate channel of the scope. This will allow us to monitor the AC line in relationship to the current. We will trigger our scope based on a one-shot and approximate over 3 amp condition. Let's get started. Competitor A utilizes a relay-assisted triac configuration. From the results of our testing, the device continuously switched at the upper peak. Switching here causes the maximum amount of inrush possible. The inrush generated is 46.4 amps. This amplifies the initial stress placed on the driver, shortening the lifespan. Competitor B claims to have zero cross capabilities. From the results of our testing, the device continuously switched midway between the peak and zero. The inrush generated is 26.8 amps. Switching here is an improvement from competitor A, yet still not sufficient in minimizing the inrush effect on the photo control and driver. Ripley Lighting Controls has perfected the art of consistently switching the load at the optimal time. From the results of our test, the device continuously switched at zero cross. The inrush generated is reduced to only 4 amps. The switching point is calculated to minimize inrush current and provides a soft start to drivers, extending life and reliability. Let's recap. Competitor A's unit switched at the peak of the waveform. This caused an inrush measured at 46.4 amps. This surge is going to not only degrade the photo control, but stress the driver and shorten your return on investment. Competitor B's unit switched midway between peak and zero, generating an inrush of 26.8 amps. Yet better than competitor A, due to the device's inaccuracy and consistency, this is not going to be a benefit, rather a detriment. And finally, the Ripley Long Life featuring ZCS technology has a proven track record, leading the industry with quality, performance, and reliability. Currently with over 500,000 units deployed in the field, all consistently switching at the optimal point, ZCS technology gives lighting operators peace of mind that Ripley photo controls will continue to operate for many years, minimizing maintenance and maximizing savings.